34,347 A6 97 A 9,996,026 A7 C 431,428. JPG HTTPS uploads.disgusting.com/images /7 E 16,456 AB 58 boldface 46 F 45 A 877 C 4 AC 185 B 27 F 69 D 454 C 4 A 0 C E674 E94 C4 CBA 170.99 decibels 7.jpg phase I GS1 compilation 2018 type text page 3 Q.2 What are local winds? How do they originate? How do they affect the local weather conditions of a region? Explain. Approach. This is a pretty straightforward question where you just need to answer the factual questions. Now if you start explaining everything or every type of local wind, it will be too incomprehensible for you to write and also to complete the answer in word limit. So it's better that you categorize the winds broadly first and then explain shortly. In the synopsis we have tried to cover almost all types of prominent winds of the world for your information. In the exam you don't need to mention them. Local winds. There are several winds which develop in response of the local terrain. They are generated through temporary creation of regions with relative high and low pressure. They are known as the local winds. They have a significant impact in the weather conditions of a place and psychology of the society. Broadly they can be categorized on the basis of periodicity. There can be periodic winds and non-periodic winds. Important periodic winds are mountain/valley winds, land/sea breeze and monsoons. Important non-periodic winds are gravity winds, Chinook, blue, etc. Some of the prominent local winds are land and sea breeze. These winds develop as a consequence of the differential heating of the land and sea surfaces. During the day, the land heats up faster and becomes warmer than the water offshore. Because of this, a low pressure area is created over the land surface and relatively high pressure area on sea surface. This causes wind to blow from sea towards the land. This is called sea breeze. On contrary, during night, the land loses its heat relatively faster than the sea, hence a breeze starts flowing from land towards the sea surface. This is called land breeze. These winds are periodic winds and regulate the temperature in coastal areas. The sea breeze has a soothing effect on the weather and increases the efficiency of the people. These winds are more pronounced in tropical and subtropical latitudes as differential heating is more here. Mountain and valley breeze. The mountain and valley breeze also has direction reversal in every 12 hours like land and sea breeze. Mountain air cools rapidly at night and valley air heats TLP phase I, GS1 compilation 2018 type text page 4 up rapidly during day. Thus warm air raises upslope during the day and at night. The cooler air subsides downslope into the valley. Katabatic winds or stroke gravity drainage winds. They are significant on a large scale than mountain and valley winds under certain conditions. These winds are usually stronger than mountain or valley winds. For these winds to blow, an elevated plateau or highland is essential, where layers at the surface cool, become denser and flow down GLP phase I, GS1 compilation 2018 type text page 5 Samoon, hot wind blowing during summers in Iran. Simoon, hot wind blowing during summers in Saudi Arabia. Sido code, hot and humid wind blowing from Sahara to Sicily during April to July. Berg, it descends from the Alps in Germany. It helps in melting of snow during winter season. Chinook snow or ice eater, it blows in USA and Canada between December and March. It descends on the leeward side of the mountain. It is warm and dry and causes the snow to melt. It has a soothing effect on weather and society. Note, in the above synopsis, the weather associated with the winds have been covered with the wind itself. In the form of an answer, you will have to mention that separately as it is asked separately in the question. Monsoon as a local wind we have not covered here, as one synopsis is dedicated to monsoon climate. Best answer 1. Amberglass https://uploads.discussed.com/images/db5b9d90098b520.319,542 to AA90F7CAA5B0BA-D307.jpg https://uploads.discussed.com/images/37DC60989JF2068cc 94 decibels 1 AAC 6341 F35BE 690A7cc FFDB 36817 D1 FE85F.jpg Q.3 Discuss the principles of plate tectonics. Examine the interrelation between plate tectonics and the evolution of the Alps mountain range. Background: plate tectonics defines the movements and features of the Earth's surface now and in the past. The theory of plate tectonics was advanced in the 1960s and 1970s to generate new information about the Earth's ancient magnetism, the nature of the ocean floor, the flow of heat from the Earth's interior, and earthquake and volcanic distribution, with the main aim of explaining how the Earth works. Approach: TLP Phase I, GS1 Compilation 2018 Type Text Page 6 mention the principles of plate tectonics and then different types of tectonic boundaries. From it you can interrelate between plate tectonics and the evolution of Alps mountain ranges with appropriate diagrams. Introduction: plate tectonics is a scientific theory describing the large-scale motion of Earth's lithosphere. There are various basic principles underlying the theory of plate tectonics. The fundamental principles include the plates. This is the principle stating that the Earth's outer shell is composed of several different hard and rigid plates. The Wilson cycle. The Wilson cycle illustrates the life cycles of oceans and continents. Particularly, it pertains to the rifting, drifting, and colliding of large continental plates to form a small ocean. Convection. Convection is the principle defining the movement of the plates. This means the movement of the plates are influenced by convection currents flowing in the heated, plastic asthenosphere layer below the plates, the lithosphere and the asthenosphere. This constitutes the Earth's outermost layer, the crust and the upper mantle. The asthenosphere plate is mostly plastic-like fluid due to its nature of high viscosity and mechanical weakness, and the plate tectonic boundaries define the regions where the plates meet. The plate tectonic boundaries are usually associated with geological activities like volcanoes, earthquakes, and mountains, as well as oceanic physical features. There are broadly three types of plate tectonic boundaries, namely, divergent boundaries. It takes place when the plates move away in opposite directions. Along the boundaries, it is common to find geysers spurting superheated water or lava spews. The process widens the giant basins and renews the ocean floor. Occurrences such as earthquakes and volcanic activities are frequent along the divergent boundaries. E.g., the Great Rift Valley in Africa. Convergent boundaries, formed when the two plates collide, ends up forming the rugged mountain range, and at times the edge of one or both plates bend the other down into a deep sea floor trench. E.g., the Mariana Trench and formation of Alps. Transformed boundaries, formed due to the effects of the plates sideswiping or sliding past each other. During the occurrence of divergent boundaries, artificial and natural structures within the edges of the plates are torn into pieces and carried in opposite directions. E.g., San Andreas Fault in California. TLP Phase I, GS1 Compilation 2018 Type Text Page 7 Evolution of Alps mountain ranges. The Alps arose as a result of the collision of the African and Eurasian tectonic plates through the convergent boundary, in which the Alpine Tethys, which was formerly in between these continents, disappeared. Enormous stress was exerted on sediments of the Alpine Tethys Basin, and its Mesozoic and early Cenozoic strata were pushed against the stable Eurasian landmass by the northward moving African landmass. Most of this occurred during the Oligocene and Miocene epochs. The pressure formed great recumbent folds, or necks, that rose out of what had become the Alpine Tethys and pushed northward, often breaking and sliding one over the other to form gigantic thrust faults. Connection dots. Please focus on plate tectonics principles and not on plate tectonics. Then mention types of plate tectonics boundaries, and please explain from it how Alps mountains has formed geologically. Diagrammatic representation is musting geography.